Hi, I wanted to give a quick video presentation on quantum field theory. I came across this interesting video the other day called Wave Particle Duality is Wrong by the channel Pattern. Go ahead and like. Um, so basically, he gives a quick rundown of quantum field theory, and what they've done is they've combined special relativity with quantum mechanics, and they've said all these things that are subatomic particles that they have modeled out for, right? They say that instead of being particles, they're actually their own individual stationary fields, and that when they're acting like a particle, that's just oscillation within their respective field, right? Um, so apparently, they can get a lot of good predictive modeling out of this, and all the math works great. But when they try to account for dark matter, dark energy, gravity, general relativity, matter with antimatter, asymmetry, and neutrino oscillations, which we'll talk about towards the end, when they try and add those together, the math, it stops working. It's all gobbledygook, right? So just a quick recap: the things that they invented to reify the theories, the Big Bang theory, general relativity, special relativity, and the Copernican principle. And adhere to the things like the Copernican principle, the universality of physical laws, the cosmological principle, like to be in line with all these things that they have agreed upon, so that they could sway science in a certain direction. Um, when those things are accounted for, they don't fit within a theory that says, like, things are exist in a stationary field that vibrates, which in my opinion sounds very etheric, but I'm just a caveman, and these equations frighten me. So uh, we'll move on now to the oscillating neutrinos, right? So okay, so first off, let's define a neutrino. A neutrino is a small particle that doesn't interact with anything except the so-called weak force, and they're electrically neutral. It may even have no mass, sources say, those sources being scientists. And additionally, uh, that weak force, it dictates like how the particles interact with each other and what they do. So like when you see the atom and all the stuff's orbiting it or whatever, the weak force would be that instead of, I guess, traditional gravity. With the affected by the Earth or whatever. So anyway, there was an experiment done to detect how many neutrinos are being emitted from the sun, and they had all this math to figure out how many they expected to detect, and they ended up detecting less than a third of them. So they came up with a math equation, and that was along with a theory that said, well, the neutrinos could hypothetically change into a different type of neutrino while they're traveling from the sun to the Earth. And if they change to a different type of neutrino than what the detector is programmed for, then it wouldn't be able to detect it. And they found out this was true because the math matched the exact missing amount uh, of what they didn't detect, right? So they found out that they were, correct all along. It's just another classic example, right? And then, it just happens to turn out that that thing, neutrino oscillations, is something that doesn't work in quantum field theory, yet it's confirmed. So they can never really go back on it. So that's the end of the presentation, and hope you enjoyed.